So for the pH calibration, we're going to have our electrode out of our pump head and into a container of water that's at a known temperature and a known pH. Normally we do this spectrophotometrically to get the pH, but for this demonstration we're just using our other Honeywell electrode as the reference electrode. We also have a temperature probe in that we're going to calibrate the temperature of our CISME electrode. The electrode should ideally be on for at least 1 hour powered up before you attempt a pH calibration. So pH calibration, this is the factor currently stored for the temperature calibration. I will hit cancel here. If I did not want to change the temperature, I would hit skip and I could skip this step. We always calibrate pH with the pump on. So I will toggle the pump on and I will enter.
And it is set for 5,000.
It's set for your toggle within your system. So our current temperature is 23.516. So 561. Dropping a little bit. Done. And we'll say calibrate. It will now take 100 raw voltage readings and average those and plug them into the polynomial function to produce a temperature calibration factor for this electrode.
Again, to reiterate, you have to know the temperature and pH of the solution of which your pH electrode is inserted into in order to do this calibration. And the pump needs to run at the same speed during calibration as that you're going to use during your experiments. We have selected 5,000 as the RPM to run our pump for our measurements, so we also calibrate it at that RPM.
And that produces the new calibration factor. If we accept this, it will be written into memory. If we hit cancel, it will reject it and use our previous calibration factor. So I'm going to accept. And now we'll move to the pH calibration step. Again, it shows us the current factors that are stored in memory. I'll hit cancel. We keep the pump toggled on. We'll enter the pH, the known pH from our buffer. 8.08. Done. And I'll hit calibrate. Again, it will cycle through 100 measurements of the raw voltage and plug that into the equation in order to be able to generate the calibration factor for this electrode. Very importantly, the electrode should have been powered up for at least 1 hour in the buffer solution that you're using before you attempt this calibration.
Once you've calibrated the electrode, in our experience, it is very stable for long periods of time. When we do field work, we calibrate the electrodes back in the laboratory, pack them up, ship them to the field, and we do a cursory check of the pH with a separate pH meter just to make sure nothing has changed, but we've hardly ever had to do any type of recalibration in the field.
Again, it comes up with a screen. We can either cancel, in which we will retain our old calibration factors, or accept, and the new ones will be written to memory. With the pH calibration, when you accept, it requires a reboot of the system, and so the system will automatically reboot now and go through its reboot process, in which case it will have been disconnected from its Wi-Fi and you will have to reconnect. It will take a moment before you'll be able to reconnect. So I'm going to hit cancel here and wait for a minute for everything to boot up. We can go back to our settings screen. Our board here is the DDF CISME Wi-Fi board. Now it showed up. I'll reconnect there. Go back to the CISME app and reconnect again. I'll toggle the pump back on. And so what we'll see now is we have a new calibrated temperature and a new calibrated pH.
You can always tell when you're connected because those values on the blue data ribbon will be all zeros if you're not connected with the CISME. And as soon as it populates with numbers, you know that you are connected.
And importantly, the CISME ID comes up.
Right, because if you have several CISMEs on at the same time, the tablet doesn't know which one to communicate with. So we have written on each CISME Wi-Fi the last 4 digits of that card, and then you need to make sure that you're connected to the right CISME when you do any type of communication via the tablet.